Okay, so whenever we're dealing with intermediate value theorem, just repeating, not on your quiz tomorrow, I want you to hone in on this word intermediate. That means between. You could say it means middle, but it doesn't mean the exact middle. It just means somewhere in between. I want you to keep that in your mind. All right, so first of all, we have an if statement, if then. Remember these conditional statements from geometry? Okay, if f is continuous on a to b, that means that this has to be true. This is what we're going to call the condition. Every time we use the intermediate value theorem, or IVT, we first have to decide if f is continuous. That's why we learned about continuity before we learned about this theorem. Okay, so that always has to be true. You don't tend to have to prove it, you just have to state it, or state that it isn't true. All right, this whole k is any number between f of a and f of b. I'll get back to that. There is at least one number c in a to b. Okay, I want you to write x values underneath that. And then the final thing is such that f of c equals k. So a lot of letters, right? So if a and b are x values, let's go ahead and plot them on the graph. And let's just draw any curve we want. It doesn't have to be an increasing, it could have been decreasing. And if a is the x value, then what do we call the y value? F of a. That's where f of a in this problem is coming from. These are the y values. So we're going to do the same thing with the b. And I kind of made these close together, but that's okay. So here's f of b. By the way, do you think that f of a always has to be less than f of b? What if I drew the function like this? F of a would actually be up here, and f of b would be down here. That was just kind of a side question. Doesn't really have a lot of relevance to the problem. All right, so this is the setup. Okay, and notice that my graph is continuous. Has to be continuous. You can't even apply the theorem otherwise. So this says k is any number between f of a and f of b. So is k an x value or a y value? It's a y because it's between these two. So I'm going to write k and then I'm going to write it big over here. It's between f of a and f of b. So they give you a y value between your two y values, and what the theorem states is that that means that then whatever the x value is has to be between your x values. This may seem like, why did we even care, or isn't that always going to be the case? But I will tell you, it doesn't work the other way around. Okay, if I just knew that c was between a and b, it wouldn't mean that k is between here. Okay, so there's a picture. That helps some of you, but I know, I've done this long enough, I know that most students really are not good until they do an example. Like, what do you really need to know how to be able to do? Okay, so let's look at the first thing. So on number 1, it says verify that the IVT applies. Okay, I'm not even going to go any further. If this is like kind of like a proof, I need to state that the conditions are met. So the conditions are that f of x is continuous on this particular interval, 5/2, comma 4. All right, you don't have to prove it, although if you kind of think about it, it should make sense. There is a value for x where this thing is not continuous. Can anybody tell me what that is? 1. But it's okay because 1 is not between 5/2 and 4. 5/2 is like 2.5. So everything is fine. All right, the next thing we need to do is actually find f of a and f of b and make sure that 6 is between those two numbers. This is the not so fun part. Okay, because it's elementary school fraction work, everybody's favorite. And I say that because it's in your brain. You know how to do it. You just don't want to do it. So this means I got to plug 5/2 in for x up here. And I am going to have to simplify because I'm going to have to compare it to a 6. Okay, I'm going to go through this kind of quickly, but I am going to go through it. Okay, so first of all, 5/2 squared, that's going to be 25 over 4. And 5/2, I'm going to rewrite that as 10 over 4 because I'm going to have to add those two fractions, and it's going to be helpful if they have the same denominator. Okay, down here I have 5/2 minus 1. Let me change that to a 2/2, so that makes 3/2 in the denominator. And that means I have 35 over 4 times reciprocal of 3/2 would be 2/3. And then the 2 and the 4 can simplify to 2, and you end up getting 35/6. So I went through that pretty fast, probably faster than most students would. Now, do you know how, is 35 over 6 close to 6?
Yeah.
Yeah. Is a mixed number, we'd say 6 goes into 35 5 times with 5/6 left over. Or you could have just thought about it as being a little bit less than 6 because 36/6. Either way. All right, so f of 5/2, that's the hardest part of this whole problem. Okay, up here, let's go ahead and do f of 4. This one's easier. So 4 squared plus 4 over 4 minus 1. So that would make 16 plus 4 is 20. 4 minus 1 is 3. And this thing is going to be a little bit more than 6, 6 2/3. Okay, we stated the condition, we found f of a and f of b, now we need to simply show that 6 is between these two numbers. So this is a way that I know is good, and this is how we'll do it. Start with the smaller of the two numbers, right, out of these two. Start with the smaller one, and let's write an inequality. Less than 6, less than 6 2/3. Then we need to relate this back to the function. Okay, what was 5 and 5/6? Well, it was f of 5/2. What was 6 2/3? It was f of 4. Okay, so thinking back to IVT, intermediate value theorem, I said what the condition was. I showed that this number 6 is between f of a and f of b. So now I can say, therefore, by intermediate value theorem, IVT, f of c equals 6 on this interval. You have to relate it back to the interval. Okay. This is your first exposure at this. You're not going to be an expert on this today or tomorrow or probably even by the test. But I just want you to get better each time we talk about these proofs. Okay, that's the goal here. What I am going to definitely be looking for by test time is that you list this f of x as continuous. That's going to be like its own point. You get it or you don't get it. I'm going to be looking for this. And then the last point or two on these problems is, can you wrap up your proof in a nice way? Okay, so let's try this again. And the context looks different, but it's actually pretty similar what we're doing. So this says, the IVT can be used to locate zeros of a function that's continuous on a closed interval. If f of x is continuous on a to b, and f of a and f of b differ in sign, meaning one's positive, one's negative, what has to go in the middle? It has to be a 0. So this says, use intermediate value theorem to show that this function has a 0. When you see this a0, I want you to think f of c equals 0. It's going to make this look more like the last problem, right? F of c equals 6 in our first example. In this example, f of c equals 0. Okay, we have to list that the conditions are right to even do this. So what do we have to state about that? F of x is continuous on this 0 to 1. And we know that it is because I know cubic functions are continuous. really don't lose sleep over whether it is or isn't. When it says use the IVT, it's implying that it will work out, so just write that it's continuous. Okay, the next thing we need to do is to find f of A and find f of B, and hopefully one of these is positive and one is negative, and so 0 will go in between. And again, this number crunching is easier to do. So 0 cubed plus 2 times 0 minus 1 is going to be just -1. Okay, f of 1 is going to be 1 cubed plus 2 times 1 minus 1, and that's going to be 2. So it's not always 5/2. Sometimes it's easier numbers. Okay, is 0 between these two numbers? Yes, so let's show it. -1 is less than 0 is less than 2. And then we got to relate it back to the function. We got to say, okay, what was -1 representing again? It's like almost like going backwards in the problem. It was representing f of 0. What was 2 representing? It was representing f of 1. And then we can wrap it up. Therefore, by intermediate value theorem, f of x, now I'm going to go ahead and use the words that they told us to use, has a 0 on this interval. Okay, there is another example on the other side of this page, and I'm going to do that one tomorrow.